Hello, my name is Junho Kim from Seoul National University. In this presentation, I will present our paper titled Ev-TTA, Test Time Adaptation for Event-Based Object Recognition. Event cameras are neuromorphic sensors that save visual information as a sequence of events. The sensors can provide measurements in scenes with fast motion or drastic illumination changes due to their high dynamic range and small motion blur. However, events recorded under extreme conditions trigger domain gaps. As you can see on the right, in low lighting, object edges tend to disappear, and in extreme motion, certain edges contain more densely packed events. These changes lead to performance deterioration, which is a big challenge for deploying event-based vision algorithms. We introduce Ev-TTA, a simple, effective test time adaptation algorithm for event-based object recognition. Ev-TTA mitigates the domain gaps from extreme measurement conditions by fine-tuning the classifier during test phase. To further elaborate, consider a model trained with ground truth labels on the source domain as seen on the left, which will make low-quality predictions in novel, unseen environments. Ev-TTA adapts this model to new conditions without using ground truth labels in an online manner. Ev-TTA performs adaptation by utilizing training objectives and denoising functionality inspired from the spatio-temporal characteristics of events. First, Ev-TTA adapts a pre-trained classifier using training objectives that enforce the temporally adjacent events to output similar predictions. Additionally, we remove noise in low-light conditions where large amounts of noise occur by utilizing the spatial distribution of events. The training objective of Ev-TTA is further divided into two loss functions. First, the prediction similarity loss enforces the predictions made on various regions in the event stream to follow the prediction on the anchor event, which is shown as the red box. Formally, this is formulated using symmetric Kale divergence, which penalizes distributional deviations between the anchor event prediction and the rest. Second, selective entropy loss enhances the quality of the anchor prediction. The loss minimizes the prediction entropy of the anchor event if its prediction is consistent with predictions made on the neighboring events. Here, the consistency is determined by comparing the class prediction of the anchor event against the majority vote made from the neighboring events, which are shown as dark blue bars in the figure on the left. In low light conditions, Ev-TTA additionally performs denoising using spatial consistency. Large amounts of noise on a single event polarity often occur in such conditions, which can be observed on the negative polarity in the figure. For each event on the polarity where noise occurred, we examine its neighbors in the opposite polarity, and if the event lacks any neighbors, we label it as noise and remove it. This allows Ev-TTA to mitigate the domain gaps from noise in low light conditions. Now we will share the experimental results on NMGNet, which is a classification dataset that contains 9 evaluation splits recorded under various camera trajectory and brightness changes. The table shows the classification accuracy in NMGNet using various adaptation methods. First, performance drop is evident in the no adaptation scenario due to the domain gap from external changes. As we can observe in the last row, Ev-TTA recovers the classification performance in most NMGNet variants and outperforms other competing methods. In conclusion, we propose Ev-TTA, a simple, effective test time adaptation algorithm for event-based object recognition. Ev-TTA adapts existing classifiers to new, unseen environments in an online manner during test phase, without using any ground truth labels. Our experiments show that Ev-TTA effectively adapts classifiers to novel environments with large amounts of trajectory and brightness variations. We expect Ev-TTA to provide the key technique for deploying event-based object recognition algorithms in challenging real-world application scenarios. Thanks for listening.